Today, we chat expanding binomials. Now, we've done this stuff before with like squareds and cubes and things. You're foiling, stuff like that. But what happens when you get into ones that are bigger, to the fourth, to the fifth? What happens if I just want a single term in there? Do I have to do the entire problem to get there? The answer to all those questions is no. So here's what we're going to do. We're going to take this triangle up at the top. Some of you may have discussed some things like this in science classes before. If you're looking at like flowers and patterns and things like that, one that shows up is what's called Fibonacci's sequence, and that actually comes from Pascal's triangle, which we're going to talk about today. But we're not going to discuss flowers. We are going to discuss binomial expansion. So, yes, sir. You can either... Oh, here's where Pascal's triangle actually comes from, though. As you work from the top to the bottom, you notice all the ones on the outer edge. As you come towards the inside, though, you might start to notice that the two numbers above any number in the triangle are the sum of those two. So, for instance, 1 plus 1 is 2. 1 plus 2 is 3, as is 2 plus 1. And you can just keep making this pattern. 3 plus 3 is 6. 3 plus 1 is 4. And it just keeps going and going and going. And it goes beyond this. I mean, it could infinitely continue this way with that same pattern. It just keeps stretching and getting longer and longer. So for our purposes, however, we're going to use this pattern with some variables to expand some binomial terms. So like, for instance, if I were to FOIL out a plus b, because that's what we're probably most familiar with, if you think about that as far as a plus b, and you'd FOIL it, a squared, ab, and ab, or 2ab, and b squared. Okay, but do I really want to have to do all of that distributing and FOILing every time? We talked about that before. No, not really. So the patterns that we used in Pascal's triangle are the same patterns we're going to use here, but there's an even cooler pattern going on here. When you start looking at the exponents of a and b, especially in some of the larger ones, when you look at the a, for instance, when you're starting with a binomial of degree 5, look at your a's. 5, 4, 3, 2, 1, 0. Kind of cool. Then your b's do the exact opposite. I have a degree of 0 in the first one, and then it goes 1, 2, 3, 4, 5. And that'll happen with every one of these rows. Combine that with the numbers we get from Pascal's triangle, and you have a way to really quickly work these out. So, my a degree decreases by 1 for each term, and my b degree increases by 1 for each term. And that's going to be true whether it's a plus b quantity to the first, to the 100th, whatever. Okay? That pattern won't change. And so it makes this easy to do some other things that we may not think about doing otherwise. So here's kind of how this is going to work. Bless you. So for instance, let's say we get something like x plus 2 quantity squared for example 1. My a value would be x, my b value would be 2, just so I can kind of look at it as far as the pattern goes. You're like, now I could FOIL that out pretty quick and get an answer. And I get that. But just to see how the pattern works, I'd look here and I'd say, okay, the pattern is a squared plus 2ab plus b squared. A is going down, b is going up. And you're like, oh, a squared be x squared plus 2 times x times 2. Okay, there's the 4x plus 2 squared, which is 4. Now, it may not be the greatest thing ever when you're just doing a squared, okay? But as you get into thirds and fourths and things like that, it gets to be a little more helpful. So, for instance, if I swing over here, and again, some of you are going to sit in your head and go, yep, well, be done faster. But my main note on this one is whatever sign goes here also is going to go with your b. So if you are using a pattern, you need to take the negative with. So like when I'm doing the squared, I'd be like, okay, so x squared, then it's plus 2 times a times b plus b squared. If I'm strictly looking at the pattern. X squared minus 6x plus 9. Same as I'd get if I'd FOIL it. But mainly showing you the squareds just so you can see how the pattern works. When I get up to thirds, this is when it gets to be a little more fun. So here, my a term is x, my b term is 4. And sometimes when I'm doing this, I like to take care of all of my a terms at once. So for instance here, so it's x to the third, then the next one will be x squared, then x, then there won't be any left. My b's go the opposite. I don't have a b term in my first one, so degree is 0. And it's b to the first. Oops, not b, Harty, 4. Ugh. 4 to the first, 4 to the second, 4 to the third. A is going down, B is going up, and then I just clean it up. So 3 times 4 is 12, so that would be 12x squared. 4 squared is 16, times 3 would be 48x, and 4 cubed is 64. That's going to go much faster than writing this out 3 times, foiling your way through the first 2, and then distributing your way through the third one. Now, can you do that? Sure. If you wanted to sit and FOIL this out and get an answer and then distribute the x plus 4 to it, you could, but it's going to take a lot longer. So when you do these, x and negative 2, you think for a second about how Pascal's triangle works. 1, 3, 3, 1. And then you just start rolling through. You're like, okay, so x to the third plus 3x squared, I'll leave a blank for my b here, plus 3x blank, and then there's nothing left for me in that last one, because again, that's just going to be my b term. So I go the opposite way. I don't have any b term. I have b to the first, b squared, b to the third. And then I just clean it up. Negative 2 times 3 is negative 6x squared. Negative 2, notice I use the parentheses. Negative 2 quantity squared is 4, times 3 is 12. And negative 2 cubed is negative 8. And like I keep saying, you can multiply this out. If patterns for some reason aren't your thing, but ooh, math, patterns are a big part of that. So kind of getting used to those patterns, at least down to 3 or 4, is something that you really want to do. So now, the only thing that can kind of get a little twisted with this, once you get the pattern, is, well, when do I start throwing in coefficients? What's going to happen? Nothing different. Okay, it's still a third, so I just have in the back of my mind, it's 1, 3, 3, 1. So I go, okay, here we go. So I've got 2x quantity, again, use the parentheses, cubed, plus 3 a term squared, I'll leave my blank there for my b, plus 3 a b squared, and then plus b cubed. And again, if you want to do them both at the same time, you can. So with b, this would be, I almost did it again. Holy mackerel, Harty. 3, my b squared, and my b cubed. And again, the reason for the parentheses are I'm not just squaring, excuse me, in this case even cubing the x, that's going through here completely. So I'd have 8x to the third. 2 squared is 4. So here I've got 3 times 4 is 12, times 3 would be 36 x squared. 3 squared is 9, times 2 is 18, times 3 is 54, x, and 3 cubed is 27. But again, it's getting used to that pattern. Even if you end up with variables in both your terms. So let's see this time. Let's see if I can kind of run them both at the same time. Now again, this is just a squared, so don't go crazy. So square my first term plus 2 times my first term, because it's going down 1 in degree, times my second term, which has gone up 1, plus my second term squared. A is going down, B is going up. And then again, be careful and make sure you distribute that exponent through. 6 times -4 would be -24ab. And again, the parentheses here are critical because it ends up being plus 16b squared, not minus. But again, the ones that we mainly will use will be the squareds and the cubes here. We might occasionally get a 4th or a 5th in just to kind of see how things are going. But again, and if you need to flip over for the pattern occasionally, that's okay. But the big thing is just remembering A's go down, B's go up, and then some things with Pascal. So let's see what else I can throw here to twist at you a little bit. Let's run over to 8 here. You're like, ooh, that's kind of nasty. You're giving me 2 variables in a term. Yeah, well, sometimes that just is going to happen. So here, I'm like, okay, it's a square again. So I square my first term plus 2 times the product of my 2 terms, because they both have a degree of 1, and then square my second term. And that squared goes all the way through on my first term. Now when I get to the middle term, be careful, that squared's not going to my 4, it's just going to that A. So 2 times 4 is 8. Times -3 would be -24a squared b. And -3 quantity squared is 9. Good to go. So don't let the extra variable terms mess with you. Now when you get to 4 though, okay, now here's a newbie. So my Pascal pattern is 1, 4, 6, 4, 1. But you just start with the largest degree on your first term. So I have x to the 4th plus 4x cubed, and now I start my b term with degree 1 plus 6 x squared. Oh.
Excuse the interruption. Is Austin Jureski in class?
Yes.
Do you have him come to student services? He's leaving.
Okay.
Thank you.
Plus 4. Again, keep going down 1 with my x. Keep going up 1 with my 3. And then finally, I run out of x's and I'm to here. Now the one thing you also, that I haven't mentioned before, which I probably should have, is notice your degree on each one in total is 4. 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. So if you ever get mixed up, just think about, are these adding up to the right number? Yes, they are. And that'll happen every time with these. And then I'm just going to clean up. 4 times 3 is 12. 3 squared is 9, times 6 is 54. 3 cubed is 27, times 4 is 108. And 3 to the 4th is 81. Just play the pattern. And that's true no matter how big they get. And this will be the biggest one we get to, but you had to have one of them. So the fifth, oh my goodness, a is itself, b is -2. Okay, my pattern. See how good I am at remembering this. 1, 5, 10, 15, yes, no, 20, 10, 5, 1. Almost did it. No, Harty. Oh, Harty, you went one past. Grr. 1, 5, 10, 10, 5, 1. That's right. I could have even just looked at this. 5, 10, 10, 5, 1. I got a little too happy. Okay. So I'm starting at 5. So a to the 5th plus 5, down 1 with my a, up 1 with my b, and just keep playing the pattern. Down 1 with a, up 1 with b. Because again, I keep getting that 5 that my degrees are measuring up to, or adding up to. A squared, b to the 3rd. A, b to the 4th. We're almost there. And b to the 5th. Whew. And clean this up. And this is going to be where the detail work comes in, making sure I don't mess up a sign or forget about something. -2 quantity squared is 4, positive. Times 10 would be 40. -2 cubed is -8. Times 10 is -80. -2 to the 4th would be positive 16. Times 5 is 8, positive 80. And -2 to the 5th is going to be a -32. Yeah, I definitely would not want to be foiling and distributing that out 4 times. This is enough craziness. So why do I necessarily want to get these patterns, memorized, besides some of these big, huge ones? Well, what if I change up the question? What if I change it up like, find the second term in the expansion of? Now, in other words, what I'm saying is, if you were to multiply this all out, like if I were to tell you to find the third term in this, that'd be the answer. That's my third term. Well, what if I asked you to find the second term in the expansion of 3u minus 1 cubed? Here's what I would be doing, and I've even got it kind of jotted down here. If I remember what the pattern is, and I know that's going to be my second term, 3a squared b, I'm not doing all the rest of it. I'm going to do 3a squared b. And I'm going to plug in the 3u where the a goes. And I'm going to plug in -1 where the b goes and just do that part and get the answer. Now, could I do the entire thing out if I wasn't sure? Sure. But again, why are we wanting to do more work? I don't understand. So when we're trying down here, find the third term in the expansion. Okay, well I remember on 3 it's 1, 3, 3, 1. And I remember it starts with A and goes down, and B, and it goes up. And you're like, well, wait a minute, it's not A and B, though, it's these. I know, but sometimes just looking at the pattern so you can figure out what you're going to plug in can be a little bit helpful. Because here now, I just say, okay, 3a b squared. I simplify that, I'm done. So let's see, we've got 3 times x times 16y squared. That is much faster than even going through all the expansion above and then just circling it at the end, if I can recognize it. And like I said, you can do the entire expansion and then just square or circle it. I'm not going to tell you that's wrong. I'm just saying, let's save you some time. With a fifth term, because there's my degree. I've got this time. 1, 5, 10, 10, 5, 1. And again, it's starting at degree 5, and it goes down 1 each time. And for my b's, it goes up 1 each time. Remembering that my degree is always going to be 5. Find the fourth term. 1, 2, 3, 4. Plug it in. Do a little simplifying. And multiply it out. And again, this just comes in handy when you're trying to find bits and pieces of things. And you don't need the whole blasted thing every single time. So to kind of get a little bit of practice playing with this, especially with the pattern, since that triangle can come in very, very handy, and so can this pattern with your exponential terms. The worksheet that goes along with this gives you some practice at this, but at the same time, it's going to let you practice a couple of other things as well. So for instance, when you get over to the worksheet here, which again will be your first one into the next homework check, first side's got you factoring it completely out. The bottom has you finding specific terms. The back, things that, no, not extra credit, things that we had issues with back in our last unit for different things that we need a little more practice on. Little things like remembering if you're completing the square, make sure all of your constant terms are on the other side of the equals before you start your process so you don't get a messed up radius. Or the quadratic formula if you need to go back. Remembering the signs, remembering b is squared, all of that fun stuff. And also that it's in standard form. Everything wants to be on the squared side. If it isn't, move it over there before you start plugging in. And then finally on the bottom, and I might give a little help here in a second. Well, why not? I feel nice. Find the discriminant. Just that, not the whole quadratic. And state the number and type of solutions. Remember, if you get a positive, it's 2 reals. If you get 0, it's 1 real. And if you get a negative, it's 0 real solutions because it's never going to cross the x-axis. Now the other two, oh, why not? Okay, quadratic formula. But this is something that needs to be in your noggin because this is going to keep showing up on quizzes and tests until I'm seeing accuracy all the time. But you'll notice the discriminant's part of your quadratic, and oh, finding the x value of your vertex is the other part. It's 2 things we've done already. We're just putting them together to find yourself a solution. And then again, completing the square, it's all about, one more little move down. I'm going to get you started on this first one. Get that 21 out of there. Then it's about taking your b value, dividing it by 2, and squaring it. That gets added to both sides. And some of you, these are the parts where you were shortcutting before and it kicked your tail. So hopefully we've learned from that and aren't going to do it again. This becomes a binomial term. Just steal it from here. Don't factor that. Just take your b divided by 2. Keep life simple. Solve it. Don't stop. Remember, when you're taking the square of a quadratic, you're going to get 2 answers. So it's plus minus, and we're lucky this time. It broke down nice. That won't happen every time. And then again, solve it. Don't do this and leave this and circle that as an answer. Negative 9 plus 8 is negative 1. Negative 9 minus 8 is negative 17. If that was a radical instead, then you can circle it. But unless that's the case, you need to simplify it all the way. So that's what you get to play with. And then I will have quizzes back to you tomorrow. And